Section 1.5 is using problem-solving strategies. So what I have for you here are 3 story problems that we're going to work through and 3 different methods you can problem solve and work through them. So since these get kind of long, if you want, while you're taking notes, if you take notes on the computer, you can screenshot the actual problem and insert it and then just do your work below it if you don't want to type it all out. The first strategy we're going to talk about is using a formula. If you know a formula, use it. That's a strategy. So the problem we have is a train travels between Wagner and Yankton at a distance of 50 miles and the trip takes 1.5 hours. We want to know what is the average speed. And for your liking, this is an actual map of the working railroad system in southeastern South Dakota. And yes, there is a train that runs from Wagner to Yankton. I don't really know what it carries or how often it goes, but there's one that goes there. So we're looking at that train. It went 50 miles, 1.5 hours. Now you might already know, if you have this type of brain, that if you are looking for the average speed, you're probably looking for miles per hour. If you want miles per hour, it's going to be miles over hours. So your answer is just 50 miles divided by 1.5 hours. And that gives you miles per hour. And when you divide that, it's 33.3 repeating. But since this is a real life answer, you're not going to put 33.3 repeating miles per hour. Just put about 33.3 miles per hour. Now, if you could come up with that right away, if you remember, there is a formula for distance. We know that distance equals rate times time. Well, the distance we traveled was 50, so now we have a formula. Just plug in what you know. We know the distance was 50. We're looking for the rate. The average speed is a rate, so we don't know that. And the time it took us was 1.5 hours. Now all you have to do is solve for r. So when you do that, you divide by 1.5 and you get the same answer. 33.3 miles per hour. So 2 different ways you can solve that. So that's one strategy. Use a formula if you know it. Second strategy, looking for a pattern. So in this one, there's going to be some pattern. So this is a strategy you can use, looking for a pattern. In this problem, it says a paramotor is a parachute propelled by a fan-like motor. The table right here shows the height in h of a paramotorist t minutes after beginning his descent. Find the height of the paramotorist after 7 minutes. So h is the height that he's at after t minutes. So at 0 minutes, so which means if it's 0 minutes, he hasn't started yet. So he starts at a height of 2,000 feet. Then after 1 second, he's at 1,750 feet. At 2 minutes, he's at 1,500 feet. 3 minutes, so on and so forth down the line. Our goal is to find out how high is he after 7 minutes. So we're trying to fill in this chart 5, 6, 7 minutes. How high is he after 7 minutes? Well, in order to find that, we should probably find out how fast is he falling. That's our pattern. We're looking for some pattern. Is he falling at the same rate after every second? To find that out, all you have to do is subtract. So from 2,000 to 1,750, if you subtract those two, he's descending 250 feet. From 1,750 to 1,500, if you subtract these two numbers, again, he's falling 250. Between 2 and 3 seconds, from 1,500 feet to 1,250, he's also falling again 250 feet, and again here, if you subtract these two numbers, he's falling 250. So it seems that as he's falling at a constant rate. He's always per second falling 250 feet. So since we know every second he's falling that far, what you can do, since we're only trying to go to 7, is really you could subtract 250 3 more times and get how high he is. So if you subtracted 250 again, at 5 seconds you would have 750. Subtract again, you'd have 500. And one more time, 250. So at 7 seconds, he's 250 feet in the air. Now let's say the problem was asking, okay, how high is he after 20 seconds? Like it was really far out there and you didn't want to keep subtracting. You can use the information we just found to write a formula to help you find the answer. We know that this guy starts out at 2,000 feet. So you're going to write that down. You're trying to find at what height is he at after 7 seconds. And you know that he falls 250 feet every second. So if he falls, you're going to subtract 250 every second. So you're going to multiply it times the time, because every single second he falls 250. So if you want how far he falls after 2 seconds, you times it times 2. After 3 seconds, times it by 3. After 4, 4. That's why we put the t with the 250. And this is just a linear equation from Algebra 1. So then, to find out how high he is after 7 seconds, you just plug in the 7, and you'll get 250. Same thing. Last method is sometimes you might need to draw a diagram if it's a long problem that has some weird things going on, like this one. You are hanging 4 championship banners on a wall in your school's gym. The banners are 8 feet wide. The wall is 62 feet long. There should be equal amount of space between the ends of the wall and the banners, and between each pair of banners. How far apart should the banners be placed? Now that's a lot of information to take in, so a diagram could be very helpful in this case. So let's draw it out. You have a wall that's 62 feet long. So here's our wall. "62 feet. And it says each banner is 8 feet wide, and there are 4 banners. So 1, 2, 3, 4. And it says the banners are 8 feet, so we'll write that each one of these is 8 feet, and that they have to be evenly spaced. So in between each banner, they have to be the same exact space. So if they're the same exact space, that means they're the same number, which means we can use the same variable for all of them. So I can just put x in all of these spaces, because all of these have to equal the same exact thing. So now we can use this information to come up with a little formula that will help us. Anytime you're solving for a variable, you're going to need an equation to solve for that variable. And the only way to do that is use what you know to solve. So, I think you would agree that this side is 62 feet. I wrote that down. Well, this side as well, unless it's some weird oblong wall, is 62 feet along with the bottom of the wall. So, if they both equal 62, that means that this x plus this 8 plus this x plus this 8, that x, this 8, all of this should add up to be 62. So you can just write x plus 8 plus x plus 8 plus x plus 8 plus x plus 8 plus x should all equal 62. So now if you add your like terms, we have x plus x plus x plus x plus s. We have 5 x's. And then we have 1, 2, 3, 4 8s. So if you add all those 8s together, 8 times 4, you have 32. And then just solve for x. So we have 5x equals 30 divided by 5, x equals 6. So that means that if X is 6, if you look back at your picture, the banners should be 6 feet apart. So your answer should be the banners should be 6 feet apart. So those are the 3 main methods that we use, and in class we're going to do some problem solving together.